Okay, we're going to talk about trig inverses, and we've been dealing with that. We know that we can find the angle if we know the fraction or the decimal that goes with the angle. So if you remember, if we had 5 and 12 like this, we could say the sine of this angle is 5 divided by 12, right? But if I want to know the measure of the angle, I have to do sine inverse of 5 over 12. And lo and behold, if I do that, sine inverse, whoop, 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 whoop. We got to get out of this program. Sine inverse of 5 divided by 12 turns out to be 24.6 degrees. So I know that this angle right here, angle theta, is 24.6 degrees. Look at that. It works on all sorts of things. So it doesn't have to just be a right triangle like this one. We could have let's see, if I told you I wanted the tangent, let's try the tangent of some negative number. What if we did something like that? Can I find answers if they're negative? I sure can. Tangent of negative square root of 3. It gives me negative 60. The measure of the angle, negative 60 degrees. Hey, how about that? Positive 24, negative 60. What if I did, what if I did cosine? Let's do a cosine one. Cosine inverse of I don't know, let's do negative 3 divided by 2. We can have all sorts of things like that, huh? Cosine inverse of negative square root of 3. Now you have to close your parentheses on the radical. Divided by 2. Then close the parentheses on the cosine. Look at that, 150 degrees. Hey! Measure of angle theta, 150 degrees. So it doesn't matter if it's fractions or decimals or anything, you know. Tangent inverse of 1.5. Well, I'll do that. Tangent inverse of 1.5. There you go. 56.3 degrees. We can find any angle we want. Ta-da! That's trig inverses. Remember, you always put the fraction or the decimal inside the formula, and what comes out of the formula, the answer, is the measure of the angle. So whatever fraction or decimal you have, that goes in to the inverse. What comes out is the measure of the angle. Ta-da! All right, we're done.